Hi, my name is Layla Lucas, and for my creative work, I decided to create electronically a collage that shows an array of parasites that have co-evolved alongside primates, since my topic was co-evolution of parasites and their hosts and its impact on human health. Many of these parasites can cause diseases in humans, which negatively impacts our health since they take our nutrients in order to survive. Echinococcus granulosus, which is pictured right here, is an example of a parasite that causes cysts, usually located in the liver or the lungs, but has co-evolved alongside humans. It began as one species, but evolved into 4 different species that are evolutionarily competing against humans for survival. Another example is the intestinal fluke, Fasciolopus buski, which is pictured right here, which is actually the largest intestinal fluke in humans, and they infect humans through digestion and then pull nutrients from the blood vessels, the lungs, the liver, or the gastrointestinal tract. While it's generally asymptomatic and can go undetected for months, severe cases can cause anorexia, vomiting, abdominal pain, and edema, which directly impacts human health. Though only 10% of parasites in humans are common worldwide, humans are the most parasitized species, and this is probably due to the fact that we inhabit all the continents and have a very wide diet. We also interact with a lot of different animals and humans where we have a greater chance of contracting a parasite. And parasitic infections are usually transmitted through oral contamination or through the skin. And ingestion of parasites affects human health. For instance, toxoplasmosis is caused by a single-cell parasite called Toxoplasma gondii, which is the leading cause of death due to foodborne illness. And it is infected about 1/4 of the world, but continues to be prevalent because anti-parasitic medicine can only stop the infection from growing. And pinworms are another type of parasite that go through microevolutions while infecting the host. And it's easier to see these evolutions in the pinworm than in the host because they're much more short-lived as compared to a primate host. And they often live in the large intestine and lay eggs on the skin when the host is asleep. And these worms adapt with the host's diet, and as they grow larger, they're more apt to evading our immune system defenses. And this is known as the evolutionary arms race, which you can see pictured here. It kind of explains how we evolve alongside these parasites. Since the host organism develops a trait that is essential in avoiding the parasite, and the parasite then develops a trait that helps to overcome the new defense that the host has. And the host also evolves in such a way that lowers the fitness cost to them, and the parasite evolves in a way that increases their fitness by taking nutrients from the host. And the ideal way for transmission to occur is a high parasite population and a host with enough survival for the infection to spread to other hosts. And host-parasite coevolution is important to study because it can help us find medicine or cures to diseases that they can cause. Though sometimes it is difficult to study because we don't know everything about parasites and they're constantly evolving in order to survive. Thank you so much for listening. I hope you enjoy.